Hey guys, and welcome to my channel. So in this video I'll be covering about relationship between the Fibonacci sequence and the golden ratio. So this is actually a continuation of the last video in which I had discussed about how to implement the Fibonacci sequence using three different solutions, and one of them being the golden ratio. So that's I just explained it in a straightforward way, but there is no mathematical explanation of why we are implementing golden ratio in to generate the Fibonacci sequence. So I'll be just covering that part in this video. So I'll be referring to this book called Discrete Mathematics and Its Applications, written by Kenneth H. Rosson's 8th edition. So let's move to the page number 565. Not exactly that. It's 542. So okay, so in here, I'll just refer to this theorem where it converts all the recurrence relationships into straightforward formula, which is independent of all the previous terms. For example, this is the formula how it should be like. This is just for all cases. So given an nth term, how it is dependent on an minus 1th term, an minus 2th term. So all if any of the recurrence relationship is in this formula, we can directly take those constants C1 and C2, put it in this form, like in this quadratic equation, get the roots, and substitute in this new formula. Uh, so in this one, nth term is always dependent only on the roots of the equation, and like basically those being the constants, and only dependent on n, and none other terms will it is independent of all other terms. So there is also a proof explained for this, and if you want to go through that, I'll just post the link for this book below. You can directly go ahead and download it from there. So I'll just go ahead and look at the Fibonacci sequence, like since our main agenda is this thing, explaining this thing. So yeah, given a sequence, a nth term will be depending on n minus 1th term and n minus 2th term. So in this case, the coefficients c1 and c2 are 1 and 1. So again, we can write it in the same format. Substitute the values of c1 and c2, those being 1 and 1 in this case. Solve for this roots of the equation and then substitute. So here the same thing has happened. So we just get the roots of this equation being 1 plus or minus root 5 by 2 being both of them. So we just substitute them as alpha 1 into first root and alpha 2 into second root to the power of n. So after getting that, we need to solve for alpha 1 and alpha 2. So for that, we just had to substitute the values of n because we already know 0th term and first term. So just substitute n0 and n1 and solve for the alpha 1 and alpha 2. So we finally get fn equals to the whole thing. And in the code, what we have used is only this first term and not everything. So the reason behind that is 1 minus root 5 by 2 is always less than 0, and as n grows larger, this part will always will go tend towards negligible, so tend towards 0. Yes. So so then the final formula I have reduced this to this one, and you may also remember that we are rounding this term. So because there are some decimal places just come to the because of this negativity and also this negligible, since negligibility is there, so we just had to round off this part so that we just get the exact Fibonacci number. So yeah, I guess that's the same. I guess that's it for the video, and yeah, if you want further more explanation on this, you can you can comment down below. Yeah, then thank you for watching.